Okay, guys, this is our fifth and final problem from chapter 6.1. Problem comes from the book, page 262. And it's problem number 6, part C. We start by defining three sets. The set capital A is equal to the set of all elements A that are integers, such that A is equal to 5k plus 2 for some integer k. The set capital B is equal to the set of all elements B that are integers, such that B is equal to 10L minus 3 for some integer L. And the set capital C is equal to the set of all elements C that are integers, such that C is equal to 10M plus 7 for some integer M. And our task is to prove or disprove that the set B is equal to the set C. Please pause the video, try to work out the problem on your own. And when you're done, I'll pause the video and I'll show you how I did it myself. Okay, I'll get started. So we start, there we are. Okay, so I'm gonna start with an aside. So the first question, before I even go anywhere with this, is what does B equal C? How do we determine that? Well, if B is equal to C, that implies that B is a subset of C, and C is a subset of B. So our task, if this is true, if we determine this statement is true, our task is to prove that B is a subset of C and C is a subset of B. Okay? I'm going to pick a variable that's not anywhere in my definition. I'll start with P. And I'm going to start with this B is a subset of C first. So I'm claiming that P is a subset of B. If so, that means P is equal to 10L minus 3, where L and P are both integers. So I'm starting with the form 10L minus 3, and I'm looking for the form 10M plus 7. The coefficients on the left-hand side is equal to coefficient on the right-hand side. 10 is equal to 10, so I don't have to multiply anything. I'll put my empty parentheses here. I'll put plus 7, which is coming from here. And then I ask the question, how do we get from plus 7 to minus 3? Well, we would subtract 10. So negative 10 plus 7 is equal to negative 3. I drop down this 10L. And I ask if I can factor out a 10 from the parentheses. I can. That's equal to 10 times the quantity L minus 1 plus 7, which is also equal to 10M plus 7, where M is equal to L minus 1, which is an integer. All right, so far so good. We know how to prove that B is a subset of C. Now let's just do the other way around. I'm not going to use P again because I don't want to get confused. I'll use Q. And so now I'm saying that Q is a member of C. If so, that means Q is equal to 10M plus 7, where M and Q are both integers. I'm starting with the form 10M plus 7. I'm looking for the form 10L minus 3. The coefficients are the same, so I don't need to do any multiplication. I'll start with my parentheses. I'll put negative 3 on the outside. And then ask the question, how do I get from negative 3 to 7? I would add 10. In other words, 10 minus 3 is equal to 7. I drop my 10M. And then I ask if I can pull out a factor of 10. I can. That's equal to 10 times the quantity M plus 1 minus 3, which we can also say that that's equal to 10L minus 3, where L is equal to M plus 1 is an integer. So we can prove that C is also a subset of B. So ultimately, we're proving that B is equal to C. Right? And this looks very similar to the other proofs. It's just a little bit more writing. So let's get started. Proof. Let P be an arbitrary but distinct element of set B. By definition, B is equal to, what did I say, 10L minus 3. Therefore, P is equal to 10L minus 3, which is equal to, I don't like doing it on the same line. Let me do the next line. Is equal to 10L minus 10 plus 7, which is equal to 10 times L minus 1 plus 7, which is equal to 10M plus 7, where M equals L minus 1 is some integer. We can conclude that every element M in set B is also an element in set C. Thus, B is a subset of C. Now we're going to do exactly the same thing that we just did, but now with the Q and with C. So next paragraph is let Q be an arbitrary but distinct element of set C. By definition, Q is equal to 10M plus 7. Therefore, Q is equal to 10M plus 7, which is equal to quantity 10M plus 10 minus 3, which is equal to 10 times M plus 1 minus 3, which is equal to 10L minus 3, where L is equal to M plus 1 is some integer. We can conclude that every element Q in set C is also an element of set B. Thus, C is a subset of B. And finally, since B is a subset of C and C is a subset of B, the set B is equivalent or equal to C. We're done. That's all the problems from 6.1. If you have any questions, message me on Discord or whatever we can do to communicate. Hopefully you guys got everything done and feel confident. Thanks.